part one is to find the velocity as a function of time. So that just means differentiate this. So it's product rule. You get 2t plus, leave this alone, and times by that. And we're going to get minus. Okay, we can simplify that a bit. We can factor out t and e to the power of t. So t e to the power of minus t, and we get 2 minus t. Okay, so that's a simplified version of velocity as a function of time. So what is the velocity after 1 second? Okay, we're just replacing t with 1 here, and we get 1 over e. C, when is a particle at rest? So that's the same as when, for what time is v at t equal to 0? So we take this, and the 0, the whole thing can be 0 from 2 places. This and this factor. Okay, from here you get t is equal to 2. When is a particle moving in the positive direction? So when is this positive? So t, 2 minus t, all over, and we're going to put that at the bottom. So this is always positive. So the whole expression will be always positive when t times by 2 minus t is positive. Now, this is a quadratic, and it's a quadratic with roots at 0 and 2. Right? Quadratic looks like a parabola. It is a parabola if you graph it. And from here you can see that it's positive right in between 0 and 2. So when t is between 0 and 2, velocity is positive. Okay. So find the total distance traveled during the first 6 seconds. Okay. Key thing here is that the answer is not via 6. Okay, so you actually have to separate the timeline. When it was going forward, we just found out it's from 0 to 2 it's going forward, and then from 2 to 6 it's going to go backwards. So the distance from 0 to 2 is, right, f at 2 minus f at 0. And the distance from 2 to 6 seconds is going to be f at 6 minus f at 2. This is going to be the total distance that the particle has traveled. Okay, so let's just plug it in now. F at 2 is going to be 2 squared, so 4 times by e to the power of minus 2. Plug in 0, it's going to be 0. Plug in 6, you get 6 squared e to the power of minus 6. And here we're going to be plugging in 2, so 4 e to the power of minus 2. Okay, so for this one, actually, we have to put an absolute value around it. I actually meant to put an absolute value around it, because it could be that this is a smaller value. We want the difference, right? We want the difference. We want to make that difference positive, right? Because so what's really happening at between 2 and 6? Let's say the graph looks like this, and this is a negative value, and this is let's just say this is -4 and -2. So if you do -4 minus -2, the answer is -2. But what we want is the positive distance, the vertical distance from this point to this point, which is +2. So we actually have to put an absolute value there. Okay, so then if we do that, this will flip around. Okay, this is bigger than this, so we're going to get 4 over e squared. That's going to become negative, so it's 36 over e to the power of 6. So this is also 4 over e squared. So we get 8 over e squared minus 36 over e to the power of 6. So that's the distance that it has traveled. The motion from a motion of the particles, basically it's going to go forward, right, until 2 seconds. And it's going to go backward after 2 seconds. That's the motion of the particle. Lastly, find the acceleration at time t in 1 second. So let's go right here. Let's grab this. Okay, we have to differentiate this one more time. So acceleration is the derivative of v at t. So we get, differentiate that, we get 1. Differentiate this and we get t minus e to the power minus t. And lastly, differentiate this and we get just minus 1. Okay, so, okay. So let's see here. Let's expand this. 2e to the power minus t e to the power minus t minus t e to the power minus t, right? If you multiply those two, let's times it by 2, and then let's times it by minus t as well. So you're going to get positive t squared e to the power minus t. And here we just have a minus t e to the power minus t. Okay, let's collect the like terms. These two are like. T minus 2t. Collect these two, you get 2t e to the power minus t. That's actually minus 4, isn't it? So minus 4. And that's the last term. So definitely we can factor out e to the power minus t. You get 2 minus 4t, right? And like this here, there's supposed to have a square, so we get t squared. Okay. That's nicer. I'm not gonna graph, the velocity and acceleration and the original particle function graph. But the last thing I'm going to do is discuss when is the particle accelerating or speeding up. Okay, so it's going to speed up in two case scenarios. When v is positive, so it's going forward, and acceleration is positive, so it's accelerating forward even more. So that's when it's speeding up. But it can also speed up when v is negative, so it's going to the left, and acceleration is also going backwards. So acceleration is also negative. So in summary, what you can do here is, well, v and a, right? If you multiply, note that if you multiply positive with positive and negative with negative, you'll end up with a positive value. So when v and a, the product is positive, we are speeding up. Okay, so v, so t, I'm gonna write the e at the bottom. Okay, and then we have the acceleration graph, acceleration right here. So t squared minus 4t plus 2. So when is this positive? Well, the bottom is always positive, so the whole expression will be positive when the numerator, okay, is positive. And this is a degree 4 polynomial. And from here we can get two roots. Using the quadratic formula, we get t is equal to 4 plus minus 4 squared minus 4ac all over 2a. So 4 plus minus, you can factor out a 4 as a 2 outside the root to get 2 minus, 4 minus 2, so that's 2. Over 2, you reduce and we get 2 plus minus root 2. Okay. So the roots are 0 from here, 2, and then 2 minus 2. So 2 minus root 2 is smaller than 2, and then 2, and 2 plus root 2. So let's arrange them in that way, in that order. Okay, and then it's a degree 4 polynomial. Degree 1, 2, 3, 4, and it's got a negative leading coefficient. So it's going to look like this. So it's going to go like this, like that, and like that. So this part can be better. You can pass through 0 there. So when is this positive? Clearly, visually, you can see it. It's positive right there. So when t is greater than 0 and less than this, and when t is greater than 2 and less than 2 plus root 2, this is when it's speeding up. Okay, so right here, that's when it's slowing down. So when t is 2 minus root 2 less than 2, and t is greater than 2 plus root 2, it's slowing down.